Good morning, welcome back to the stoichiometric equations class 4. Today we will see the limiting reagent. People have a lot of confusions on limiting reagent. It is very simple. We know the stoichiometric or balancing equation. Any reagent in the reaction, the reactant which is insufficient to the balancing equation is called a limiting reaction. I think what? First we have to write the balancing equation or stoichiometric equation. Then whichever is less compared to the balancing equation reagent, that is a limiting reagent. Whichever is excess compared to the balancing equation is a excess reagent. Simple example we will see, that is hydrogen reacting with oxygen gives water. So balancing is 2H2 equal to 2H2. This is a balancing equation or stoichiometric equation. In this, 2 moles of hydrogen is reacting with 1 mole of oxygen gives you the 2 moles of water. If everything is like this, it is a balance. No excess, no limiting reagent. By chance, any of the reactant, either hydrogen or oxygen, is lesser than the balancing equation, that is the limiting reaction. Anything which is excess to the balancing equation is excess reaction. Very simple. Please remember once again. Okay. Now we will go to some of the problems. Simple problems. Right. Now volume to volume. Earlier we have seen mass to mass, mass to volume. Now today we will see some volume reactions of the stoichiometry. The question is, what volume of hydrogen at STP is required to reduce 0.79 grams of copper oxide, that is cuprous 2 oxide, to give copper and water. This is the problem. How much is the hydrogen required at STP condition? What is the volume? Now simple, write the balance equation, means hydrogen is reacting with copper oxide gives copper plus H2O. Here hydrogen is in 0 state, now it has the +1 state, +1 valency. Copper +2 has become 0. Okay, this is the reaction and it is a balanced reaction. 1, 1, OO, H2, H2. So balanced equation. What is the now? One should know about the molecular weights. Molecular weights, copper is some 63.5 and oxygen is 16. Total is 79.5. That means 79.5 grams equal to 1 mole. And hydrogen is 1 mole. 1 mole of hydrogen is reacting with 1 mole of copper oxide. 1 mole is nothing but 2 grams. Grams is not required actually here. Use copper and water. Right. Now the given question is 0.795 grams. Here before going to the problem, one should know 1 mole at STP conditions, 1 mole of compound gives 22.4 liters. This is the most important. 22.4 liters volume occupies at STP conditions by 1 mole of any of the gas. Right. Now given is the 0.795. That means it is 1 by 100th of mole. 1 mole is equal to 79.5 grams. 0.79 means 1 by 100th mole is copper oxide. So hydrogen also should be 1:1. So hydrogen also should be 1 by 100th mole. Very simple. Now answer is very simple. So for 1 mole it is 22.4 liters. 1 by 100th mole equal to 22.4 by 100, nothing but 0.224 liters. Very simple. Okay. We'll go to next question. Next question is also under volumes only. Calculate the volume of oxygen. Calculate the volume of oxygen at STP required to complete to burn the 100 ml of acetylene. So oxygen and acetylene is, now one should know about the formula of immediately acetylene. Acetylene C2H2. So C2H2 is reacting with oxygen, gives CO2 and H2. Any hydrocarbon, carbon and hydrogen when reacting with oxygen gives only carbon dioxide and water. So is it balanced? So here it is 2 C2, 2 CO, 2 H2O, H2, 5. So it is 5 by 2. Simple. Or otherwise we can multiply the 2 also. So 1 mole of acetylene, 5.5 moles of oxygen gives 2 CO2 and H2O. 2 to the 4 plus 1, 5 to the 4. Right. So this is a balanced equation. Now what is the question is? Question is how much volume of oxygen is required for burning of 100 ml of acetylene. This is 100 ml. Volume. Now 1 mole reacting with 5.5 moles gives this one. Now oxygen is how much is asked? 100 ml of acetylene. 100 ml of acetylene means it is, if I am converting into the liters, actually 1 mole equal to 22.4 moles. If acetylene is 1 mole, oxygen requirement is 5.5 into 24. So simply 100 ml of the acetylene, how many? This thing. So 100 ml into 5 by 2 moles of oxygen into 1 mole of oxygen equal to 22.4 liters by 22.4 liters. Why 22.4? 1 mole equal to 1 mole. So it is nothing but 2.5. So 250 ml of oxygen is required. Very simple. 1 mole of carbon acetylene is 22.4 liters. 100 ml means 100 into 22.4. 100 by 22.4, and 5 moles of oxygen equal to 5 by 20, 22.4. 22.4, 24 per cancel, and 250 ml of oxygen is required. Very simple. Okay. Next question we'll see. This is a slightly different mass percentage. Mass percentage, very simple mass percentage question. Sodium sulfite, sodium Na2SO4. Sodium sulfate is, in the sodium sulfate, what are the different mass percentages? So first total percentage we have to take, then individual masses. Sodium is 23 into 3, 2, 46, sulfur equal to 32, oxygen, sodium is 46, sulfur is 23, 32, oxygen is 64, 4 16 is 64, right? Then total weight is 4 plus 2, 6 plus 2, 12, 1 4 5, 5 plus 3 8, 8 plus 6 142, total is 142. So in the denominator, for any percentage, denominator will be total weight. Sodium percent, if somebody is asking, sodium is 46 by 142, that is the sodium, nothing but something like 32 point some 4% roughly, easily calculate. Then sulfur equal to, sulfur is here 32 by 142 is something like 22.5% roughly. And oxygen equal to 64 by 142 means the double to the earlier, so around 45%. So total equal to 45 plus 30 is 77 roughly equal to 100%. So it is very simple. Next we will see one more problem, simple problem. Sodium carbonate is 424 into 10 to the power of 6 grams is produced. This is sodium carbonate. Very simple. And methyl alcohol is CH3OH. Methyl alcohol is 320 grams, 320 into 10 to the power of 6 grams produced per annum. Which is moles wise, which is the more? That means mass you convert into moles. That's what he is asking. Question. Very simple. short, very short, that means multiple choice question. Sodium carbonate, how much is the weight? Sodium carbonate is 46 plus 12 plus 16 3 is 48. 60 plus 106. 106 means 106 grams equal to 1 mole. 424 into 1 10 to the power 6 equal to 424 by 106 into 10 to the power of 6 equal to roughly 4. 4 into 10 to the power of 6 moles. Methyl alcohol you take, methyl alcohol is 320, methyl alcohol is 12 plus 3, 3 means 4 plus 16, 20 plus 30, 32. 32 grams equal to 1 mole. Now 320 by 32 into 10 to the power of 6 equal to 10. Means this is 10 into 10 to the power of 6 moles. The earlier one is 4 into 10 to the power of 6 moles. So methyl alcohol is more. Very simple. Thank you very much. Tomorrow we will start the normality, molarity, molality, mole fraction. Simple these things. Okay. Thank you.